Good evening, everybody. This is Adrian with SuspectSky. I want to introduce the audience to a theory that I've developed known as the Covert Dark. This is a theory that I'm often going to revisit in report and discussion videos such as this, as new evidence and different modes of thinking are discovered that enhance our understanding of this possible solution to a Fermi paradox that I've developed over a number of years. So in the Covert Dark theory, I'm suggesting that intelligent non-terrestrial civilizations are out there, but our means of detecting them have so far failed, largely due to the fact that these civilizations are motivated to hide themselves from other civilizations. And this simple statement, it can be expanded to include a vast number of very highly mysterious phenomena that are visible to us, such as the Boetes void, that we are simply misinterpreting because we are such a relatively primitive civilization. But more on that to come in future videos. I thought of the Covert Dark and the idea for this theory after reading Roger Griffith, his 2015 publication entitled The G-Infrared Search for Extraterrestrial Civilizations with Large Energy Supplies. And this is basically what we on this channel refer to as a Type 3 civilization. This is a civilization that is so advanced that it has the power to harness all of the energy of its host galaxy. And according to Griffith, these apparently do not exist. Albeit he only scanned about 100,000 galaxies out of the billions out there in the universe. But still, statistically, one would imagine that at least one in these 100,000 galaxies would display signs of a Type 3 civilization, especially if life is as abundant in the universe as we all expect. Well, when I came up with the Covert Dark after reading this, I argued at many venues and outlets across the web, and especially at our annual Observing the Frontier conference, that the issue with Griffith's paper, in my opinion, was that he was looking for signs of Type 3 civilizations' waste heat, which he argued would have to be visible if they constructed these megastructures around their stars that we assume they need in order to support their exponentially expanding population. And that there would have to be a discrepancy between the visible light of the stars within a galaxy hosting such a Type 3 civilization and the infrared heat that would have to be passed through the shells of these megastructures that encased their host stars. These megastructures are often called Dyson Spheres, swarms, modified Dyson structures. There's a whole array of varying megastructures that we expect advanced civilizations to build in order to maintain their populations. Arguably, they would have to give off waste heat because they would be built to encase their host stars. Well, for years at these conferences and various web outlets, I've argued that the waste heat hypothesis did not really hold water because it made too many assumptions, the primarily being that advanced civilizations A would not be motivated to hide their presence from potentially hostile neighbors, and B, that even if they were motivated to hide themselves, that this several million-year-old civilization then could not build a structure or have the technology around the majority of their galaxy stars, would not have the ability to, say, develop an advanced recycling technology to mask most of the waste heat that its megastructures were producing, or at least that could be detected by a primitive Type 0 civilization like ourselves, according to the Kardashev scale. Well, I'm not sure if the authors of this next article that was published in April of 2018 were listening to me or not, but they have suggested a method to detect Dyson Spheres. So this is the full traditional enclosure of an entire star. This is a true Dyson sphere, and not, as we discussed quite a bit on this channel, the various modified versions that these Dyson structures could take that would seriously complicate things, but that these scientists have now suggested a method that does not depend on detecting waste heat. And so it kind of seems like our civilization is getting a little sneaky in its detection methods, which is good, because as I argue in the Covert Dark hypothesis, that these civilizations are going to try to hide these easily detectable signatures of their civilization, such as waste heat. So it's good to be seeing some progress being made in how do we detect these civilizations that are trying to hide themselves. Well, this new project involves the Gaia Satellite, and this is a satellite that stares at almost every star within our galaxy. And this will allow us to search for Type 2 civilizations. These are civilizations that have not quite yet reached the Type 3 status, where they are building Dyson structures around virtually every star in their galaxy. These are civilizations that are advanced enough to build a Dyson structure around their host star only. And these, the Gaia Satellite will be looking for these, or can be used to look for these types of civilizations and these types of structures within our own Milky Way galaxy. So I personally just find that really exciting because it's kind of close to home. It's not, 100,000 galaxies, millions of light years away. It's a little bit closer to home. The team that is using the Gaia Satellite to do this type of research, they're looking for the unusual dimming of stars, like the famous, and I'd like to reiterate, still unresolved mystery of Tabby star. That's that star that has that unusual dimming of 20-25% of its total light, which is still very mysterious. But what this satellite does, it's not just looking for unusual dimming, it's also looking for the apparent position of a stellar object changes relative to Earth. And this is a phenomenon known as parallax, and we've been using this type of detection for decades. That's actually how Pluto was found. But Gaia will look to measure the distance to a particular star by triangulating its position between a different star and the Earth, and deviations in its position would indicate the presence of some other gravitational object that we can't see is affecting it. This is kind of the basic principle of parallax detection. So what does all this mean in a nutshell? This means that the Gaia Satellite, if used according to the way this team is proposing, it can detect covert dark objects because of the gravity that those objects are influencing on the target star that the satellite is looking at. Well, they actually tested one candidate, and it was a star labeled as TYC 7169-1532-1, which was a star that had something very large disturbing its position in this sort of parallax effect. But after a bunch of careful studies, the team concluded that it was just a nearby white dwarf star and was not one of these covert dark objects that, at least at this channel, we're all hoping that they find. But what I found very exciting is that this satellite will use this parallax detection technique to look for nearby Dyson sphere candidates that are both optically dark and infrared cool. And this is something that is really in accordance with the Covert Dark hypothesis that I came up with, which is that these civilizations are likely going to try to hide themselves, and they're going to take advantage of any technology they can to minimize waste heat, reduce the ability to optically detect themselves from their sort of potentially neighboring hostile civilizations. And out of the billions of stars that is at the disposal of this Gaia satellite, it just might find an ancient alien megastructure whose creators decided to be covert. Well, anyway, just wanted to quickly thank the audience very much for listening to this report today, and look forward to more reports, more investigation into this hypothesis known as the Covert Dark, and because there's a lot of objects out there that I've been tracking for the last few years that I'd like to share with everybody, and how all that kind of plays into this idea of the Covert Dark hypothesis. Just wanted to quickly thank the audience for listening, and to remind them that we are living in some interesting times right now. Until next time, this is SuspectSky signing off.